Our last quadrilateral that we're going to study in Chapter 8 is a trapezoid. A trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. So, because it doesn't have both pairs of opposite sides parallel, it's not a parallelogram. The sides that are parallel are called the bases. So, in our picture up here, segment AB is a base and segment CD is a base. The parallel sides are the bases, segment AB and segment CD. The other two sides that aren't parallel are called the legs. So segment AD and segment BC are legs. AD and BC. At the end of each base, we have a pair of angles. At the end of DC, we have angle C and angle D. We call those a base angle pair, or a pair of base angles. Angle A and angle B also form a base angle pair. There's nothing particularly interesting about the base angle pairs until we move into a type of trapezoid known as an isosceles trapezoid. Then they become a little bit more interesting. If you want to take a second and pause this now, you might want to get the vocabulary terms down. They make easy quiz and test questions. I'm going to go ahead and proceed, assuming you've paused if you needed to. Okay, we don't have a lot to work with in terms of problems with these trapezoids. With regards to angles, we would know that the same side interior angles along either leg have to be supplementary, because that's a property. So same side interior angles for parallel lines. Let's suppose this is a 70-degree angle and this is a 120-degree angle. You might be asked to find the values of x and y. Now, knowing this is 70 doesn't help me out with y at all, because there's no relationship necessarily between these two. And knowing that that's 120 doesn't help me with x. What we know, though, is that x must be supplementary to the 70, because it's same side interior for this pair of parallel lines and transversal AD. So x has to be 110. Over here, these two guys are same side interior for the two red lines and transversal BC, so they have to add up to 180. They are supplementary. So y has to equal 60 degrees. And that's about all we can do with a basic trapezoid until we start adding some more things to it. Now, let's suppose that this is what we're going to call an isosceles trapezoid. In an isosceles trapezoid, we have the property that the legs are congruent. So if I have an isosceles trapezoid, we have congruent legs. Bases could never be congruent, because if they were, then you'd have one pair of opposite sides both congruent and parallel, and that would make this a parallelogram. And trapezoids are not parallelograms. Now, another property beyond the sheer definition of what an isosceles trapezoid is that if a trapezoid is isosceles, then each base angle pair is congruent. So base angles are congruent. Which would mean if I knew this guy here is 75 degrees, then angle C has to be 75 degrees. So angle C would be congruent to angle D. And this base angle pair is congruent. Not to these guys, but to each other. So if that's 75, remember those two have to be supplementary. This would be 105, so that they would add up to 180, and that guy has to be 105 as well. So the base angle pairs are congruent, angle C congruent to angle D, and angle A is congruent to angle B.